Hey everyone, if you are enjoying these videos, go check out my website at www.apcsexamprep.com. I have information on boot camps and tutoring availability along with other AP Computer Science resources I think you'd enjoy. Hello everyone and welcome to Greenfoot Basics Video 2. Today we're going to be creating a Catch the Apple game. Here you'll see some falling apples and we have a basket and we're trying to collect them. As time goes on, every 5 seconds the speed increases. We try to avoid the bombs. They're randomly falling at random times and in random X locations, but always at the top of the world. This game has a 30-second timer, 3 lives, a score counter, so we'll be working a lot with that functionality of counting and storing values and keeping track and having different things fall at different times with different randomness. And so let's get going. So if you want to grab my starter code, you'll go to apcsexamprep.com and go to the Greenfoot tab and be able to download a GFAR file to get this set up. To add in an object, all you have to do is click on the class and hold Shift and then click. And then if you right click the background, you can save the world and it will auto code the code necessary for adding in this object. So if we save the world, it will create this prepare method. And the prepare method prepares the world for the start of the program. That is, create an initial objects and add them to the world. And we can keep adding to this and resaving the world and it'll update the prepare method. But for this, we just need to have one object in to start. And then we need the apples and the bombs to automatically fall on certain time. So like I've said before, what I really like about this series is I've created guided notes with comments. And so I really encourage you guys to try to do this to-do list on your own and then watch the video and see how I did it and see if I add anything that you didn't know into the commentary. And just, you know, the way to be a good programmer is to try to solve problems on your own and think like a programmer. It really won't help you much just to copy my code down. Pretty much just look this up on AI anymore and find whatever answer you're looking for. So I don't feel like I'm giving away anything that you guys couldn't look up on your own. It's just that I'm able to explain it and teach you what it means. And hopefully you guys will utilize this and learn from it. So yeah, in our orchard world, we have the most code. And that makes sense because we're adding a lot of values in the demo you saw at the beginning. You know, we're adding a lot of values in and they're falling at a specific rate, but we also have a timer, a score counter, and a number of lives. So we have a lot of stuff that are happening in the background, not our individual objects like our apples and basket and golden apple. They're just falling. So let me update my golden apple and I'll make sure to update that for you guys so you guys will have that for the starter code. So in programming, it's best to break things down into steps. So let's try to solve one problem at a time, such as adding an apple in randomly. And so we can look at our to-do list, set up these variables for you, add a basket object to the bottom of the screen. So we already actually did that in the prepare method. You can hand write this code and do it like this, or you could set basket to new basket instead of creating it as a lowercase basket variable. Basically, this lowercase basket is the value of what's after the equal sign, just like our lives is equal to 3. So when we plug in lives, it'll be replaced by the value. So you could have used new basket. What creating a variable allows you to do is to store this as an individual basket that you can use over and over again, and you can, you know, adjust it or do things to it as you see fit if that's what you want to do, but not entirely necessary and not, you know, all that much complicated code there. So the act method, call a method to randomly spawn apples, bombs, or golden apples. So we need to figure out where a random value is. So I noticed down here it says Greenfoot.getRandomNumber, and that is something that is useful for utilizing randomness. So I would know that it's from the Greenfoot class. And so I can just go do my control space and look at it and know that it is a random value that you plug in an int and it returns an int. So based off that, it tells me, and I also just know that this will whatever I plug in, it'll return a random value 0 up to, but not including 10, so 0 to 9. So I could say if Greenfoot.getRandomNumber equals 1, I could do add an apple in. Now, how do I add an apple into the world? Well, if I was able to add my basket by doing add object basket, I could do add object, and like I said, this is a variable, but really its value is new basket, written out like this. And this is what we call a constructor, which we'll go over more in later videos, but it is how you construct an object. So it's just new, and then the name of the class, and then open close parentheses. And so if I'm creating a new apple, and this is just for testing purposes, like even in my demo, you guys can decide what the best values are, and you can be like, you know, the beta testers to see how to improve the game and make it, you know, more challenging and more fun. So that's completely up to you. Now the X value, we don't necessarily want the X value to be in the middle every time, or 281, which is, yeah, size of 600, so 300 would be the middle. So, but our Y value, we do know we want it to be 0. And so our X value, we want it to be a random value. So once again, I can use Greenfoot.getRandomNumber, and I could store it as a variable, and, you know, change that value or plug in that value. But this is just happening on one line. I understand what's happening, so I don't think separating it out is necessary. It just makes my code a little bit longer. I could even write a comment that says, you know, add an apple at a random X value in the world, but, you know, a Y value of 0, so it's up at the top. So now when I run the code, now I'm adding in way too many apples, way too often, way too fast. So why is that? Well, this is getting called 60 times per second. So basically 60 times per second to get a 10% chance of landing on the value you're looking for would be about 6 times per second. So that's far too often. I would think something like, you know, 40 would be more what we're looking for. And again, you can adjust this as you see fit. So we had 1, 2, then 2 happened in a row, 3 happened kind of in a row there. Okay, and it just kind of goes at a random pace. Now, we'll know better, and it'll be more based on the speed that you decide to set your apples to. So you can set location, and we did this in the last video. Get X is going to be where your X value is when you add in. This will always stay get X because our apples aren't moving side to side. So then our Y value would be the original Y value plus, you know, 2 or 3. We could start off with 2 and kind of increase it by there then. I've also added a bonus at the end that we will do that you don't necessarily have to do, but it's a speed multiplier that adds to our speed as the game goes on. So every 5 seconds we'll add to that. So now we'll see some apples falling down. Okay. Now our basket still hasn't moved. We're not removing them at the end. We'll kind of cover that stuff, but yeah, it's actually a pretty decent amount of apples and at a pretty decent speed. So for now, that should be fine. So now I notice my basket isn't moving, so I'll go to my basket and move left and right. So we've done this in previous video of Greenfoot.isKeyDown with a string parameter saying we require a string in order for this method isKeyDown to work. isKeyDown will return true or false. True if left is pressed down and false otherwise. So you actually do have to press left in order for yourself to move left. So again, set location, you're going to set it to its X value. But since we're moving left, we're getting closer to that left side, which is the 0. So you would subtract, and then get Y would not change because you're moving left. And then if else So I guess if you had both left and right down, we would have you not move at all, which I think is fine. I don't necessarily, if you have an if else here, or if else if, you have a little bit more control with the if than you do the else if. If both are pressed down, it would keep moving left because this would be true, so it wouldn't check the else if there. So you just kind of want to be aware of that. Using both ifs are fine. They're both going to get read. So now both are pushed down when I do that, and then I'd collect them. You know, I'm able to collect. I'm not able to collect all of them if they're, you know, really far away. So yeah, I like that. And so now, what else do we have? Check collision. This can stay in our act method. It's short enough amount of code and clear enough on what it's doing that I don't really mind it staying in the act method. However, if you have much more code than this, really, you should definitely put it in its own method. Here we have check collision. If touching an apple, so if is touching apple.class, we want to remove that apple. So we've done this in the last video again. So remove touching this collision. We've done the apple class object that you are touching. You could probably just copy and paste this for the other apples as well, because all of that will be the same. If touching a, so this is, but adding the score will be different, but we'll talk about that. So even with a bomb, you want to remove it, but obviously something different will happen. We'll lose a life. Golden apple will need to add 5 as opposed to add 1. Now, where do we keep track of our score? So in our basket, if we touch, we remove the object, but our score is going to be controlled and kept in our world. So that's where we want to increase or decrease your lives or increase your scores. So we'll write that code in here. So we'll have a timer, end game if lives is 0 or time is equal to 0. So let's make sure our other objects fall and we remove at bottom. So let's just do the same code for apple. So a cool thing we can do here is actually public void fall int speed. And I pre-wrote this, but this is a good example of inheritance. Like we have an apple class, and then we have a golden apple subclass of apple. So in order to do that, you can either right click or 2-finger click and then create a new subclass here. Or in my golden apple up at the top, instead of extending the actor class, I extend the apple class. Also, if you ever want to change the name of the class, you just change it. It'll update over here. But anyways, the golden apple is a subclass or a child class of the apple, so it inherits everything that the apple has. So anything that the apple class has that's public would be inherited by the golden apple. So if I was to say fall and create a method here, I could move this method in here and I say I'm going to plus by whatever speed I plug in for this parameter. So I'll say fall 2. Now, the apple still falls 2. Now the golden apple, because we inherit all things that are public, it will fall 3. And there's ways we can test that without having to write the code. We can just hold shift down and click and then run it, and you can see that that apple's speed is faster than the red apple's. So really cool thing with inheritance. It makes it a lot easier when you're making multiple classes that are going to be subclasses of something else, and you want all of them to, you know, do the same things. If you had an animal class that they would eat and sleep, you wouldn't have to rewrite the eat and sleep method over and over and over if you had 10 different animals in there. So something to think about as you're building, you know, these different programs. So remove at bottom. Okay, so we are only at the bottom. So, you know, we could use if is at edge normally, but we start at the very top. So we are at the top edge, or we could be right on the edge on the right or left side. We are using a random value that for the X that is across the entire board. So it might be best to do if get Y is greater than or equal to the size of the world. Now, we could look up in the orchard world, I think it's 400. Yeah, so we would say 399 would be the max size. So greater than or equal to 399. However, the more proper way to do it, so you can adjust the size of your world, is to access the world class set of methods. So that would access this class of methods, and you could call any method in there. One of the methods in that world class list of methods is get height. So we've done this before in the last video, where you can do get world dot and then you do control shift and control space, excuse me, and it gives you different methods than if you just did control space right at the beginning, where you have the Greenfoot methods but also all the actor methods here, because we're in an actor class. If we did it in orchard world, we wouldn't need get world method, and it would automatically, if I did control space without doing anything else, writing anything else, it would automatically populate the world methods, because orchard world is a subclass of world. So we inherit all of those methods automatically, just like our golden apple to our apple and our apple to our actor and all of these to our actors. So, yeah, removing an object is something that the background would do. It's something that would happen in our world. And so it would be a get world method dot, and then if you do that, you have to re-click and then do control space. So remove object and individual actor. So what object are we removing? So we don't have a remove touching. Here we need to reference a specific object. Like what is the object? So, you know, in other ways we might have to identify what object we're looking for if it's some other object, but in this case it is the object that is at the bottom of the world. So we can use a keyword that is called this, that refers to this object that we're already getting the Y value for, and that's falling at 2. So it's this object's Y value, and if this object's Y value is at the bottom, then we remove object this. And so you could do that. Again, you could create a method and do that in Golden Apple. That would be the better way of doing it. But for the sake of time, I'm going to copy and paste there. And then in the bomb class, I'm also going to copy and paste. Now, bomb is not a subclass of apple because a bomb is not an apple. Okay, it works differently. So we don't want to have it as a subclass because we might have different things happen with the bomb. The only time you would make a subclass if it is a relationship. So a golden apple is a specific type of apple. A bomb is not an apple. So fall down, yeah, so, you know, we could kind of copy and paste the code from 4 plus, 3, I think is pretty good, a little faster than the apples. And then we're good from there. So we run our code now, and we only have apples falling, but we can test our bomb, and we can test our golden apple, and see if they get removed at the bottom, and see if their speed is good there. Boom, boom. No, they don't get removed at the bottom. So this is where I messed up. So if I'm talking about the height of the world, that's 400. Like I said, it was 399 is the very bottom because our top value is 0. So if the size of our world is 400, we have to do -1 here. You could do equals equals. I don't know. I just get used to making this a very finite boundary that if somehow it got below that, the size of the world, which it can't, I still want it to be removed. So now we've only done it in golden apple. I think we only made that update there. So if I need to just throw this in here just to make sure, and then that gets removed. So I make the same update on apple and the same update on bomb. again, why it's nice to have inheritance is I would only have to update one method that would fix it for all of the subclasses. I mean, there's only one right now, but theoretically, you could make multiple subclasses that would all inherit that, which would be nice. So now the apple should work. We know the golden apple works, and then the bomb should work. So boom, boom, boom. Okay, great. So now we need to add the bombs and the golden apples the same way we added the apple. We want to have 3 of these, okay? And we want to less often, so that would need to be a greater number. Let's say 70 to 1 chance that a golden apple falls. And let's do a 60 to 1 chance that a bomb falls. Now, I don't know that this is the best. These are the best numbers. Again, you'll have to test these out. But, well, we got a lot of action here, which isn't the worst thing in the world. But probably need to increase all of those numbers. So let's do 60, 100. Remember, this happens 60 times per second. So a golden apple is going to fall really almost a little more than every other second. So let's do every, every 2.5 seconds. An apple falls about every second. A bomb falls about every 2.5 seconds as well. And then let's go from there. There we go. Nice. Okay. Yeah. So that's looking a little bit better here. So now let's have our basket actually be able to collect. So if it's touching a bomb, remove it. Why is this not happening? Well, we never called check collision into the act method. So you need to make sure that's on the to-do list. You need to make sure you actually call the method. Otherwise, nothing's going to happen. So make sure you call it now. Collect. Bomb will we collect. Okay, so next we're going to go in and decrease the timer each act to display score, lives, time. Okay. So we have score, lives, and time. Decrease timer each second. So time minus minus. So this would happen 60 times per second. So if you left it at 1,000, what is that? 10, 15, 16 and a half-ish seconds. I like to probably change this to something that is divisible by 60 so that it's, 1,800. Would be 30 seconds. End the game if lives is equal to 0. So if lives equals 0, and then you can use shift in between backspace and enter. There are these pipes, which is the or time equals 0. Then we can end the game. So let's see, do we have a method that we're going to write that shows status? Show status that we haven't created yet. And then we will do Greenfoot.stop to end the game. So show status can be the next thing that we do. So show status will, well, it's a showText because we're already in get world. So showText, game over. Score plus score plus quote space time plus time. Now I added those spaces so that this score variable is not right up against time. So make sure you add a location, which would be the center of the world, get width divided by 2, and get height divided by 2. How do we decrease lives? So since we're doing all of this in our world method, or our world class, orchard world, we would want to public void decrease life, and we are going to just say lives minus minus. and then public void increase score int amount. Now, we're doing this because we're showing the text and utilizing the variables inside the world by showing the text, showing the time, showing the lives. All of those things are getting shown, so we'd want to make sure that we're showing that. Oh, we have a spawn objects method, so this shouldn't be in the act method. Here, and it gives us examples. Okay. Here, now we made up our own 1 out of 60, 1 out of 150, 1 out of 150. Okay, and then call spawn objects. Okay, increase score will be score plus equals amount. So this will add amount to score, so we can change it based off if it's a golden apple or regular apple. So now we need to do our basket for if we hit the bomb. So we need to call these methods. Now they're public methods, but we need a way to access the orchard world. If I'm looking at my code, I would always do this command shift to see, you know, what do I have, or control shift to always check what I have access to. And it's going to be something similar to get world. So perfect, get world of type, and then orchard world. And it will tell me when I do that control space get world of type, that it's going to return the object of orchard world.class, similar to this getting the apple object that it's touching. So we could do that and then use dot. So just like we do get world dot to access methods in the world class, you can use the name of the thing, the class, dot, and then you can reference methods in it. So we can still do control space with this, even with the methods that we have available for the objects or the classes we've created. So orchard class is something we've created. We do have access to all of the world methods when we reference an orchard world because they inherit them. But what we also have access to is, you see, decrease life. That's not in the world class, that's in the orchard world. So we're on the right track here. So we need to increase score, and then we need to plug in an amount, and then we can copy and paste that here, even though this will cause an issue, but we'll fix that in a second. I want you guys to see the issue and maybe see if you can predict what the issue will be. We will, even if we put in 5, we're only going to add 1 when we touch a golden apple, and we'll talk about why here in a second. So here we want not that, we want, what was it, decrease life, and that doesn't have a parameter because you're just going to go down by 1 no matter what. So we'll check on that increasing score by 1 instead of 5 when we add in the show text. But what we can see is if our lives goes from 3 to 2 to 1 and to 0. Okay, so it stopped, it showed, and we're good. Okay, game over, score 0, time 1220, so we'd want to divide that by 60 so that it is per second, so that would be, you know, however many seconds. And then we want to show all of those other things, so not just when the game is over. So I did that wrong with the show status. We're going to move this show text for when the game is over, and that's going to be by itself in here instead of the show status. So we're still going to basically have that, but now we're going to do show text, and I kind of like to do the control space anyways and then get it so that it gives me the parameters required, especially for this one with 3 parameters is a little bit. So we need a show text of our score plus score, and we can put that at 75. It's kind of like a little bit of a guess and check situation. We'll do 75, 75 for the first one, and then copy, paste, 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 and we'll do lives lives. So this will be kind of more towards the middle, but we need to leave some room for, and the Y value will be 75. Leave some room for like the typing out. It has a lives has a width, like the text there. So we want to leave some room so that it's centered as much as possible. And then we have time plus time divided by 60 to make it into seconds. And this will be 450 maybe, and we'll just see how that works. So I like to put this both in the constructor so that it shows up right at the beginning, and in the act method so that it's showing all the way throughout us running it, and it updates. Okay, that's necessary. So yeah, all right, so 75 is too far, so 50, and then we can increase both of these by a little bit. This one a little less than the other. So we could do even probably less than that. We could probably do like 40 for the Y values. This would be 275, and then let's just do 5, 3, 5, 10, and that's good enough for me. So our score, does it update? Yes. It only updates by 1 for the golden apples, right? But we put an increase by 5. So why is that? If we go back to this code, our basket, I mean, we have increased score by 5. All right, but the golden apple is an apple. So it reads first this, that it's an apple, even when it's a golden apple. So it also inherits the type, the fact that is apple, well, a golden apple is an apple. So it reads this on that line. So we need to swap these two if statements. You could do an if else in this scenario, but swapping it will first, it goes line by line, so it's good to see that evidence of like golden apple. Okay, we'll remove that golden apple, we'll do this code, and then it won't be touching an apple anymore because we just removed the golden apple. So that should fix that. And apple should still work. 1, 5, 7, yeah, so add 5, add 1 more. And there we go. And then, you know, this is pretty good right here. So, I mean, you could do this and test, you know, maybe you want your bombs to fall a little faster, probably. Maybe not quite too many apples falling. You decide exactly what you want to do. We haven't gone through the whole thing on the timer, so we need to make sure that the timer stops the code as well and shows your score. Okay, score of 54, time of 0. Perfect. All right, so it looks pretty good. That's what we're looking for. So the last little bonus, choose to do this or not. I like to add this in just for a little bit of fun and teaching us a little bit about static variables. So once you make something static, it is a class variable and it is not able to be changed by individual objects. So all objects of all the apples falling, if we created a static variable, would all have the same value no matter what. Even if we wanted to change them, we couldn't. However, if we created our apple int speed equals 2, and then we plugged in speed here, we could have different apples have different speeds. We could update and manipulate this and have individual objects have different values for that. But once it becomes static, they all have to be the same. So that's a disadvantage, but when we're talking about a world, there's really only one world that we're working with. So speed multiplier is kind of what I was thinking we would use for that. So we're going to increase the speed multiplier if time mod 300, so that'd be every 5 seconds, equals 0, because time divided by 300 would have to have a remainder of 0. So at 1800, 1500, 1200, 900, 600, 300, and 0. So 60 times 5 is 300, so I know that would happen every 5 seconds. I would take my speed multiplier, and I'm just going to add 1 to it. And then the next time through, time has gone down, so it's no longer divisible by 300. So it wouldn't add again until the next time it's divisible by 300. So then I would go into my Apple, and here I made speed, but I could do speed times. Now, how do I access that speed multiplier? Well, you can do the name of the class, because it's a class method, orchard world dot. But I want you to be careful doing this, because there are times when this will kind of wreck your game or your code. So you don't want to do this unless you know what you're doing. Speed multiplier. And we would want to make this not private, but public. So that makes it a little bit tricky there. I will update that in the original version. And then now our Apple should go faster every 5 seconds. So 27, 26, 25, faster. 23, 22, 21, 20, and then at 19 it'll go even faster. And you could do this to all of them, and you would do the same code, and then you can make your bombs a little bit more challenging, and you also would do this to your movement of your basket. That way that also keeps up with the speed, so you're not missing all sorts of things. Just makes it for a more fast-paced game, and the game evolves as time goes on instead of just having a timer. But yeah, that is it for Catch the Apple. I hope you guys enjoyed, and let me know if you have any questions. Thanks. I hope you enjoyed the video, and don't forget to check out my website, apcsexamprep.com, where you can get more information on boot camps and tutoring availability.